So, multitasking. All right, so if we want to incorporate buttons, because right now we have the automatic counter, we were going to replace, we think, what's actually the clock signal that's creating the count, right? So this is our ones-digit counter down here, and the reason why it keeps counting automatically is because we had this clock signal that's automated, right, that just keeps pulsing. So we want to replace that wire, okay, that's clocking our ones-digit counter. And we want to, now I might already have the component. Do I already have it up here? Yep. I'm going to use button 0. Button 0 is actually on the S7 chip. So I'm going to take button 0 and I'm going to connect it to the input of this counter. And that is it. Okay? We've simply replaced this automatic signal that's counting, right, oscillating 0, 1, 0, 1, 0, 1, with a button. Now, on this counter, we had the inverter here, so that makes it a negative edge-triggered input. So when you try it, what you want to see and kind of test is if right, the button that's unpressed is a 0, and when you press it, it becomes a 1. So you want to kind of like slowly do it, like when I go from 0 to 1, so press and hold the button, does the counter increase? Right? And then, when you let go of the button's value goes from 1 to 0. Then does the ones digit increase? Like, right? When does the count actually take place? Is it on the 0 to 1 transition, or is it on the 1 to 0 transition? So, you should kind of know the answer to that if there's the inverter here. And we're saying it's negative edge triggered, but you can look for that. Okay, so do I need to do anything with the tens digit? No. The tens digit is already being clocked right here, okay, with something that's conditional on our ones digit counter. So that's the same. We want that. Like, that's good. So literally, it's now going to count from 0 to 80, and upon 81, it'll reset back to 0, 0 without us doing any other change. The only other thing we want to try to change is using a second button. So I'm going to go get, I had another button up here. And making this button be a button that resets the whole counter. I can annotate that this will be like a reset button. No matter where we're at, that we can press this button and to reset back to 0, 0. So this button, the first one, is simply our kind of next customer button. You know, you finish helping a customer, you press the button, and the display now says now serving. If we were on 23, it'll then go to 24. And the counter's not going to go up until we press the button, until it kind of let it know we're on the next customer, right? So it's now manually counting. So the Deli people are always slow. All right, so let's think about resetting. We already have a reset on the ones digit right here, okay? There's kind of two inputs for the reset, but remember we really only had, we're only using one of the pins. So we're kind of saying, hey, if we have the right scenario, it'll reset. Using both is kind of like a built-in and. Both of them have to be a 1 to reset. So we kind of have one tied high so that we only need to look at the other pin. And when it's high, the ones digit will reset. So quick reminder, when are we resetting? We had an OR gate, meaning there's two different possibilities to reset. One of them is coming from here, which is when the ones digit sniffed out the number 10, or the value 10. The ones digit can't display 10, so it's going to go to 0 next. And then we would, right, clock the tens digit to increase. So we're resetting the ones digit when we got 10. Okay? And that same signal clocked the tens digit. But this one, this was sniffing out, okay, there's an inverter, but kind of keep going backwards. The main logic here, kind of you see like a NAND gate, is combining these two things together, and that's sniffing out from the tens digit the value 8, and from the ones digit 1. So we're finding out when did we get 81, and when we hit 81, we're supposed to reset. So in essence, we're resetting the ones digit when it's a 10 or when we've gotten on both displays 81. We just want to add yet another condition, another case in which we reset, and that's now the button resets. So I'm going to change this OR gate. I'm going to say replace component, and I'm going to go to a 3 input OR gate. So that gives me another pin. Let's kind of loop that around a little bit. Nope. If you pan with your scrolly wheel when you're trying to make a wire, the wire disappears. Okay, so I'm adding simply another condition or another case with the OR logic that could trigger the OR becoming a 1. And so it's the button. So with an OR gate, right, I only need one of those things to be a 1 to trigger a 1 at the reset. So if two of them happen at the same time, an OR gate will still be a 1. If you have 2 1s or 3 1s here, you'll get the 1, but you only need at least 1 1. So we have 3 different things that'll do that. However, we also need to reset at the same time the 10s digit, right? Not just, this is only resetting the 1s digit. So going back up to how are we resetting the 1s digit is we're using the clear pins, okay, to make those D flip-flops go back to 0. So it's kind of this whole web right here, right? All those wires. And feeding those wires is the output of this NAND gate. It kind of came right from here, right? Okay. So, I'm going to kind of delete and think through reworking. I'm going to slide this inverter a little bit, just give myself some room. Okay. I'm going to kind of think about feeding this right here. Okay? So, I only have one case that's clearing, and that was the 81. But I want 2 cases. I want the 81 or the reset button. So that makes me think that, I need like an OR gate. Right? And so then I could say when that reset buttons, okay, I'm getting that as an option to trigger reset, or I'm looking at this. Now, this 81, the logic we had a NAND gate because of that clear, but now I need to feed this into an OR gate, and the OR gate, on this side of the OR logic, I want to test for this, I want to really be looking for a 1. So I could add an inverter, but that's like an inverter and then an inverter is a double inverter. I might as well just lose this inverter on the NAND gate and go back to a regular old AND gate. So I'm going to replace this NAND gate with an AND gate. And then, right, when the 81 happens, that logic level 1 is now a 1 coming out of an AND gate, right? And then that 1 can go into an OR. And now either the 1 from the 81 logic or the 1 from the button pressed triggers a 1. And then coming out of an OR gate, I would have a 1. But I need a 0 going up to these clears, right? So then I thought, well, you know what? If I really need a 0 to go up here, I could, instead of bringing in an inverter right here, I could just make the OR a NOR, right? Because otherwise I need an inverter somewhere to go into here. So I'm going to make this a NOR. And now that's a 0, and that's prepped to clear that. And I already have an inverter from before. We were already before used to having a 0 feeding those clears, so that 0 inverts to a 1 to hit this other clear down here. So basically, in the end, to summarize, I changed this NAND to an AND, and I added a NOR, okay, so that the 81 from the AND gate is one of the pins to the NOR, the other is the reset button, and either of those ones, right, will trigger the OR, which inverts because of the NOR to a 0 to clear, and the 0 will invert before it gets to the other one. So that's it. It's not the exact way you have to do it with inverters. So there's a little bit of playing around with inverters. So, instead of getting rid of the NAND, some people have an inverter, but, you kind of have to find what you think is your cleanest way to incorporate that stuff. So if you want to do that, you can do it. You can try it. It should work.